Hello, Happy New Year, and welcome to the first edition of the 2020 Saratech Enablement Series. Thank you so much for joining us. Presenting today, we have Dan Nadeau, who's an applications engineer for Saratech, and he's going to be talking to you about Femap 2020.1.
Thank you for the introduction. Hello and welcome. My name is Dan Nadeau. I'm an application engineer here for Saratech. My primary focus is Femap, NXCIE, NXNASTran, and NXCAD. So as Andrea mentioned, today I'm going to go over what's new in Femap 2020.1. Along with that, I want to go over some tips and tricks. I have a couple extra topics just to make sure we fill in enough time to go over output manipulation, some data surfaces, and data tables if we get to them. Now, Femap is on a 6-month release schedule, so twice a year it's going to come out with new releases. So the latest one is 2020.1, and it's highly recommended that you install the maintenance pack 1 with it. So if you have an installer right now, it does install the maintenance pack 1 if you grab that one to be downloaded. Highly recommend to do so. So the first thing that you'll notice when you open up Femap is the new icons. So it's all icons have been replaced. And some of the powerful things is when you have these higher resolution monitors, such as 2K, 4K displays, it shows up better and you get better dexterity, and the contrast looks really well. When you define new materials, properties, regions, etc., under the color, before it would just list the number, but now it lists a number and the physical color. So when you go ahead and you set a color for, we'll just say material in this case, in this one it's showing us blue, but if you wanted to change the color, you could change it there on the fly. Before, you would just enter in a number and then you'd have to remember that number to know what color it is. And these colors can be controlled under the view options or under the cube pull down color width, such as element color, property colors, and material colors. Now a simple trick here is if you right click on one of those entities in the model info tree, you can select color and then you can do random. This is pretty powerful if you read in a PDF file that says, we'll just say has 100 properties. Well, if you want to organize your model or display it, you can go ahead and change the color of them and then just view them based on their property. It makes it easier to visualize it. You can also right click and say group, and that's another great way to go ahead and help organize your model of BDF that you read in. We have full control now over digits. Under file preferences, you can go to the graphics tab, and inside there is a digital control, and there's 2 options in there, locale and then options. So you see in the bottom right of my screen, I have digit options and digit locale. And there are a couple different methods that you can go ahead and change, like a classic, you can specify your exponent, significant figures, etc. Now locale is used to specify global options, your style, decimal zeros, if you want to have a positive sign or negative values. And this is really useful if you are doing reporting or you want to make sure things are consistent. Now, if you want to control individual digit controls, because those other ones were globally, you can go ahead to your view options, and things that you control are like load vectors, contour criteria style, contour arrow options, free body vectors, loads, etc. When viewing CBush elements, now you can go ahead and plot those element coordinate system. This is very powerful to when you are defining these entities to make sure that you are entering stiffness in the correct direction. It'll automatically update if you change the orientation of this element. In the meshing toolbox here, there is geometry editing for feature editing in the meshing toolbox, where you can translate and rotate surfaces on the fly. It acts very similar to other synchronous technology that is used within the CMOS platform, such as NX. And all these things that I'm showing you right now, I'm going to go over with demo models to further explain them. So now we have the ability to remove blends. It was already there, but now it is, we'll just say, revamped. So it had some issues doing step blends as shown in the bottom left. So it does a better job now, though, of removing them. So you just specify remove blends in the meshing toolbox, select the entity, and it'll try to go ahead and remove them all. Sometimes a second pass might be required, and it might take a little bit more time, but it has been greatly improved. Now, for blend removal, This is just global blend removal. We have local blend removal, which we'll discuss a little bit more as well. And that's using the meshing toolbox or using geometry solid extend. Now for washers, you have the ability to align them to a curve or based on a vector tangent to curves. This existed for pads for a little bit in the meshing toolbox that came out, I don't know, say a couple years ago. But now you have the ability to go ahead and align them. And as you can tell in the image down here, you can see where you specified is where those split lines occur. And the reason why you might want to change it is you want to further break down the geometry using commands like point to point, point to edge, edge to edge. Tools check mesh interference command. So this is used to determine if any edges of any line, planar, or solid elements pass through any other elements. This is useful to go ahead and visualize. I used to have to, say I did a workaround, is I'd select one element using any sort of command, and then inside Femap there's a pick option to say add all connected elements. So in instance, you selected one of those elements, and then you say pick add all connected elements, and you'll be able to visualize that. This does it at a global level, which is really nice and convenient. Tools check sum force command. You originally were only able to do one at a time. So if you had 100 load sets, you would have to sum loads. If you wanted it for every load set, you would have to sum it for every individual one. Now you can specify selected load sets or all load sets at one time, or the single load set as was before. The nice thing is you can send it to a data table. So if you want to sum these forces to and then send that information directly to the data table, and then from the data table, it's in tabular form. So if you wanted to copy it to Excel or use it in any sort of reporting, you could go ahead and do that. Just like the previous one, model load from output. This existed before, but you could only do it for one output at a time. So what this command does is it creates a load from output. So in this instance, let's just assume that we ran a thermal analysis, start at time 0, go to time 10, and an increment of 1. We're going to have 0, 1, all the way through 10 as an output set. So if we wanted to use that temperatures to map to a thermal structural model, we could go model load from output. Before, we would have to specify, hey, what time would you like to create a new load? Now you can go ahead and specify whatever output sets or whatever output, or you can specify all output sets at one time. It's more convenient, it's faster, and it's easier in this case. You'll notice there are some other options depending on the type of loading that you specify. Mesh edge skin elements. It has been streamlined, so it's easier to go ahead and run through this command. If you think back to, we'll just say Femap version 11, you would have to, this would take a couple extra steps. When they added this new selection box, it made it much easier, but now it's even easier. So you have the option, which I think is pretty neat, that you can say model free edges or model free faces, depending on if you want 1D or 2D elements. So this image is showing you a 1D, but if you wanted planar face on, say, top of a hex mesh, you could say free faces. But it'll go ahead and grab them for you. And I'll try to explain this box a little bit more when we go in the example. If you are doing 1D elements, you can automatically apply element offset. So if you wanted to offset these elements on the fly, you could go ahead and do that. Now there is an interactive GUI inside the pre-post processor here to write monitor point 1 to monitor point 3 cards. In the bottom left corner, it's showing you what solutions it's supported with. It's very easy to set up, and it prints this information directly to the FO6 file. So for instance, you specify what type of contributions that you'd want, if you want to include nodes or elements, what you want a summation about, where you want the summation point, and that'll go ahead and print it directly to the FO6 file, and you can interrogate that later in the model. If you are using DMIG, direct matrix input, there is a interactive GUI now to go ahead and specify these DMIG files. For viewing topology optimization solution 200, the isosurface plots have been greatly improved to have a positive cap and a negative cap. you'll be able to see right there with the positive cap in the bottom right, get a nice representation of that load path for that structure. New output vector ID ranges for elemental output. So the ID ranges have been adjusted. You'll notice here on the left-hand side, plate bottom was 7420, now it is 9020. Now, the important thing to notice here, and this is really important for people developing APIs, we don't want you to use IDs anymore. You now want to use the FE results ID query object instead of using IDs. So be careful with APIs. Okay. So I want to go over into Femap and show you guys a little bit about what I discussed. And if anybody has any questions, please feel free to let me know. So the first thing that I talked about was digits. So under File Preferences, under Graphics tab, there is a tab right here for digit control. You have your locale and then you have your options. So I'm just gonna show you a couple of these as well. So under options, right now it's Femap Classic. Let's just say for some reason, number of digits, I want to increase this. For some reason, I'll just set 5 and you can hit this preview button and it'll go ahead and show you 5. If you need more significant digits, you could go ahead and specify that. And you'll notice that everything in the screen, I don't know if you can tell, but these entities in the screen have been updated. Let me go ahead and that should maybe help. So Tools Preferences, File Preferences. And there's the classic. If you want to make sure you have exponents on these entities, you could go ahead and have exponents on them as well. So it's easy to change these things, and they're just changing it globally for your model. If you want to make sure you're consistent, you could go ahead and change that. Now, if you want to change individual entities, you could say View Options. And inside here, maybe these load vectors I want to change. I could go ahead and change load vectors. And there's right here digits. And then for some reason, I want to make sure that they are an exponent value. I could change them without changing, the scale over here. So it gives you full control over the entities in the model. The next simple example that I have here is just simple model. I have a couple different C bushes. Some are coincident and some are not. And if I go over here in my model info here, properties, and some of these have no orientation defined on the property itself. So the elements themselves have the orientation. And these other ones have orientation that are referenced to a coordinate system. Well, maybe these ones, I don't know what is their, when I define my property, well, I didn't know which one is which degree of freedom is which. It's confusing since I didn't define it here and it might exist somewhere else. Where the one that I define a property, well, I know that they're referencing this orientation. Now to visualize this, I can say View Options. And then inside here, I can say Element Coordinate System. I can show the coordinate system, and now I can visually see the coordinate system for those entities. And you notice the ones in the middle are a reference to, I guess I shouldn't have hit OK here. The ones in the middle here are referencing this local coordinate system. So if, in this case, if I cared about this direction, I could define their X stiffness or one stiffness in that form. But in some case, maybe, oh, well, this one, I didn't define it correctly. Maybe I needed to reference something else. I could always go ahead and edit that element. Just grab this one, I guess. And actually, I wanted that to reference a different coordinate system, or I wanted to specify with a node or vector. However I wanted to define it, I could go ahead and define it. I'm just going to go ahead and specify the other one because I know it'll point the opposite direction. And now you see automatically on the fly that updates and it shows me those new degrees of freedom. And these other ones that are referencing this coordinate system, if I needed to, maybe some reason I wanted to edit to reference the global rectangular, I could go ahead and change that. You'll notice that they update there on the fly. And we even have visualization for the ones that are coincident. So it's pretty powerful when you're using C bushes to be able to tell which degrees of freedom you were adding stiffness to. Simple model. I have a bunch of blends in it. If I want to remove the blends, there is feature removal blends, and it works well on this model. You can specify it. You can always limit the size, and it goes ahead and it removes all blends. But sometimes you might have issues, and you might have to do that a couple times. But I want to show you, maybe you have some troublesome geometries. There's a couple different ways to go ahead and grab that. You could say blends. I'm sorry, not blends. You could say surfaces. I like to use this dialog select here. Select entity, and you could say, hey, pick add connected fillets. And it should grab all connected fillets to that. And you can go ahead and delete those blends. Another way that you can do that same command is you could say geometry solid extend. So I'm going to do the same thing. I'm going to pick these fillets down here. And basically, in my mind, this is working sort of like a replace face synchronous technology. So I want to take these blends and I want to extend them down to this bottom face. And I guess I misclicked there, but that will go ahead and replace that face down to the edge. So I'll go ahead and I'll run that through one more time. Surface solid extend. Let me just go ahead and make sure I grab the correct surfaces. And hit the highlighter. Make sure I get the right ones. And extend down to a face. So I think I misselected a surface last time, but you see I went ahead and replaced that face, and I removed that blend using that command. I'm just going to go ahead and step back and show you a couple more changes that they have added. Under this feature editing, this is where you can take a surface, you can translate it. There's translation modes, so there's default, auto, normal, interactive. So interactive, I'll use this first. You specify an entity, and then you specify where you want it to translate. In my case, I want it to go in the Y direction. If I hit OK, you see that moves in the Y direction. So that's interactive. Where default, you specify the vector. And then I can specify a distance. I don't know a good value, but I'll just put 0.5. And if I hit this button again, you'll see that this thing is extended in 5 units. Now there is some smart selection action going on down here. So I can hit unclick like offset in this case. So if I hit offset, it's just offsetting that top face. So you'll see that would be the offset. And then you could do something like identical. So now I'm just moving that one. But if you toggled on and you had identical in that case, it would move these surfaces that are also identical to it. So that's that identical off as well. You can do this for concentric, collinear as well, and tangent edges. So pretty neat depending on if you have some of these commands on. So that is pretty neat of translating surfaces as well. Now there are some other things like rotate surface. Now that I mess this up, let's see if this still works as I plan. So I want to rotate the surface about my global Z direction. And I want to rotate, I'll just say, 5 degrees. So make sure I have identical. And if I select a surface, you'll notice this part and this part are all moving and rotating that 5 degrees as I specify. And since this is a meshing toolbox, everything will automatically update. And I'm going to toggle off identical again. I'm going to go ahead and specify this face. And you notice just this face moves, not the one that's attached to it. So using some of these commands, you'll see we can create drastically different parts. You see I even created a hole, I moved it too far. But you can always switch this vector if you wanted to and try to go the opposite direction to fix it. So that's a pretty powerful tool. This model, I went ahead and solved it. I have multiple cases. I have 20 cases. And I want to run thermal structural analysis, I want to run a thermal structure run. So I ran my thermal, now I want to run structural. So I want to go ahead and create new loads. So I could say model load from output. So I want to grab temperatures. Now before we can only do one single, but now I can say, oh, well, I want to do it for all sets except case 0. And I want to know what their temperature is. And this will automatically create loads for me over here, time 1 through time 20, which are mapped from there. And I can visually see it. Well, there's numbers on my model. I'll show you later how we can visually see what that is. Edge members command. So maybe I have a 3D entity and I want to create this face on top of here. Or maybe I want to create 1D elements on the edge of this thing. So first thing I can do is I can say mesh edge skin members, planar elements on faces. So this, it wants me to grab things that are adjacent to this element. I can highlight it. And you'll see I create a property right there. And that has been streamlined. That used to, a couple years ago, that used to be a lot, I'll just say a lot more difficult to do this. Create a nice copy that exists at the same location. That's that matching plate. Now, for this instance, I'm going to say mesh edge skin elements, line elements. And this one, I want to do model free edges. Now, the problem is when I hit from 6, it shows this many elements. That's the entire model. So you can change this filter by hitting from elements. You can hit delete. You can hit whatever's visible. But even though those things are on the side of my screen, they're still visible. So if I hold down shift, I make a box, control, circle, control plus shift, polygon. So it grabs free edges. I'm going to use my T section that I define. I'm going to define a vector, and it automatically, hey, do you want to apply an offset? In this case, I don't have an offset, but if you wanted to, you could hit yes. And now I can visualize with thickness and cross section that I went ahead and I put that T section. If you wanted to further break this down using geometry editing, you can go ahead and put things like washers, and now you can include non-circular washer edges around these things if you want to, increase mesh density around these entities. So this one I would, you could put a pad if you wanted to as well. Optimization, they added for post-processing the isosurface plots. So now you can toggle on the positive cap and the negative cap. So you can see what material to keep and or remove. Makes this easier to visualize. So you can say, oh, well, this is stuff that I'm not going to use anymore. And then you could say, oh, this is the stuff that I'm interested in keeping. Makes post-processing this information much easier. Created a simple model to demonstrate monitor points. Create a monitor point, go over here, manage, create a new load or an arrow monitor, and you specify what contributions, what nodes or elements, what summation that you're interested, and where would you like it. So in my case, I created a reaction down here and an applied load. And I just wanted to make sure that, hey, and I'm showing a free body diagram just to double check my math, I guess. So I applied 400, I got 400 back. And if I look at my monitor points in the FO6 file, it's located down here. And now I can see that, hey, my applied load was at 400. And then down here at my reaction, I had my 100 minus 112. And my very small value here as well for the Z direction. All right. Now, I have about 10 more minutes. I wanted to cover a few more things real quick that I think is pretty useful here. So creating a data surface, it's under Tools, Data Surface, and then up this top is where you can hit this down arrow and you can see the data surfaces that you can create. Data surfaces can be saved within a model. And you can go ahead and edit, reload, edit those things, delete them, full control over them. I'm going to spend a little bit of time talking about a couple simple ones, but there are other data surfaces that exist. A common one that I use, I'll say most of the time, if I'm trying to get information from somewhere, from another model into a new model. Maybe I have thermal run and I want to map it into my structural model and we don't have mesh that is the same. We just have the same coordinates. So they're going to give me a location and some sort of value, and I can map that into my model and it'll interpolate and give me the right values. Pretty straightforward. You have a location and a value. Another data surface that's used pretty often is an equation data surface. You want to apply a load that varies with some sort of distance, or in this case, they want to apply a bearing load, and they use this equation. A bearing load has now been added into Femap and is directly available, but it wasn't before, so you would have to use this equation data surface to go ahead and create that load. The other one is load set combination data surface. So you can create new load sets based on existing sets. So what you could do is you could just copy. So say we started out with a G in X, Y, Z. You could just copy this into another one and then multiply that value by 10 and add the other one and multiply 10. It's just a lot of manual work. So what this does is using a tabular form or maybe an Excel spreadsheet, you can go ahead and combine these loads together and manually create them. So instead of manually creating them, we use the spreadsheet and it'll automatically list them out for you to do the new load sets. So this would be if you're doing it manually, and this is via the data surface editor. You can do the same thing with output. So if you want to do a combination, linear combination, envelope, RSS, you could do that as output. This is just scaling output. The nice thing about doing it this way is you don't have to run it back through Nastran. Once you have output, there's output manipulation. This is output manipulation process. Now inside here, you have output that you want to process. So at the top, you specify what you want to process. Do you want to use all output sets, or do you want to specify the certain output vectors? All right. Then you specify what operation do you want to do to your output: linear combination, envelope, RSS, error estimate, convert, etc. Then you have some sort of output that you want to process. Maybe you're interested in just translation, stress, strain, etc. And then you specify what output that you want to process. So case 1, case 2, case 3, case 4, etc. And this is easier when I'm showing it as well. So a common one, very common, is an enveloping of output. So in this case, you had 9 cases. It's going to envelope. It's going to tell you either the max value, the minimum value, or the max absolute value, whichever one you specified. And it's going to tell you what set that came from. So this is useful to figure out which set was the worst for a certain area. You'll be able to see that as an envelope output set information. Now, what I want to show you is a way to do this if you have laminate results. Maybe you have 9 cases in our case, and you want to know the von Mises stress across all plies. So this instance, you could say one or more selected output vectors, and you can create envelopes right here within output sets. And then you can say across all output sets. So within output sets is case 1, case 2, case 3, case 4. And across output sets is case 1 through 9, so all of them. So right down here I wrote the max for each output set and max throughout all load sets. So you'll get in the individual case, you get a max value, and then you'll get an envelope across all vectors. Now, one little tip right here is there's this add similar layer ply results. So instead of me going and hitting ply 1, ply 2, ply 3, you just hit this, you select one ply, and it'll grab all the plies for you. Briefly wanted to talk about data tables. So this is a way to go ahead and get information from your model. It turns it into tabular information. The common ways that we're going to use this is list output. And in my case, I'm going to show you results to data table. And this is where you go ahead and specify entities that you're interested in. We'll just say nodes or elements. And then you can go ahead and specify the output set. So in this instance, maybe I'm interested in T1, T2, and T3 and total translation for 17 nodes in my model. I can go ahead and specify that, select the nodes, and it's going to list it for me in a tabular form. The other common one is summary to data table. It goes ahead and it lists the max and the min for all nodal and elemental data. All right, so let me open up Femap and show you some of the stuff that I talked about. Looks like we have a couple more minutes. All right, so here is a very simple model. It's just a plate that is long, and I have a coordinate system that is sitting at the front of this, and I want to create a load that is based on this coordinate system. And I'm just going to do something simple. And for here, I'm going to create a new load, and I'm just going to call it force. And it's going to be a nodal load, and I'm going to apply it to every node. And it's going to be, I want to see Z direction, sorry. And it's going to be applied in the Z direction. I'm going to type 1 times, and I'm going to use a data surface. You can create the data surface here on the fly. And I'll say equation data surface. And you specify the coordinate system that you want to use. So I'm going to go with my load coordinate system. And in this instance, I'm just going to say, we'll just say exclamation X. So I'm just varying it in the distance of X. So the first row nodes will be 1, 2, 3, 4, all the way through. Now I could do like minus X or this value minus 10 or whatever I wanted to do for this equation. I'm just going to keep it pretty simple right now. And it's going to apply that load to the model. So you'll see I did 1, 2, 3, 4, all the way through the model. I don't know how well that's showing, but that's what I did. Now, it might be hard to visualize this, or maybe you had some different equation, right? So what you can do is create a new output set. So you can say model output, create a set, and I'm going to call this force load. So now I have a new output set that I can post-process. I don't have anything in it, but I have a new output set. So now I can say model output from load. I want to know my nodal forces. And what that did, and you can see in the message window, it created output vectors for me. So now I can go ahead and post-process that because I put information in there. And I can visualize that load as a fringe plot. So this is useful if you have a drastically different load. Mine's pretty straightforward. It's just going from 0 to 100. But if you had some distribution from somewhere else, you could go ahead and do that. Now, another thing that you can do is maybe you have a list, and I got this from somewhere else. I got all these, just say, forces from somewhere, and they vary with distance. And I need to map this to my model. So I can just go ahead and select these entities. And it gives me X, Y, Z location and a pressure. So I can say Tools, Data Surface Editor. And I'm going to say an arbitrary 3D data surface, and I'm just going to paste them in there. So now I have a location and a value. So if I wanted to create we'll just say a new load, a force. And this one is going to be on the nodes again. And I'm just going to apply 1 times that data surface, arbitrary 3D data surface. And now I have new loads on the model. Now these are not the same uniform value, and I could do the same thing that I did before. I could say model output from load. I'm going to put it in that same set just to save some time, but I can post-process this, and now I can look at this fringe plot. And it's the same thing. I just varied as I went up and across, but it's different than the one that I looked at before, and I could easily map information that I got from somebody else into my model. This model, I have a couple different loads on the model, and I have a combination of the model where somebody combined load set 2 and 3 and 4 and 5 and 6 and 7. So using the tools data surface editor, I can do load set combination. And I'm going to grab all my load sets that I'm interested in using. And I'm going to create this one as well. So the first one is I want case 2 and 3. And the next one I want case 4 and 5. Next one I want 6 and 7. Now, for some reason, just because I want to try something else, I'm going to do 2 times every one of those. And now here's the trick. If you right click in this empty space, there's this create combined sets. Now, you'll notice I didn't give it an ID, so it put the first one under ID 1, which is okay. But it created new combinations of these here on the fly. Now, if I want to do the same thing, but I wanted to do with output, you could do result set combination. And you can grab whatever output that you have, and you can sum it just like before, and then you can create process result sets. So it's doing the same thing, except I'm not creating load sets, I'm creating output sets. All right, so now I went ahead and solved it, and I have these 9 cases. So model, output, process. First one is enveloping. So I want to envelope the max value from all these sets. It will go ahead and process that. It should take a moment. Now, what I get out is the maximum. And in this case, I'll say, T1 translation. Translation. And then I tell it what set it came from. So this one, it might make sense to use like a criteria plot, but this is listing which set it came from. So if I have issues with this edge of the wing, I need to be looking in the set down here, where if I'm having issues up here with T1 translation, I'm interested in a higher set value. So I would want to look at this case right here, which probably has a higher value. And you'll see somewhere in the middle, I have this load set 9, which is causing more issues. So it lists the set that it came from, and it's listing the max through all of those cases. Now I want to show you one last output process. And that's, like I said, for enveloping for the laminate information. So I want to grab output across all sets, max value. I want to make sure I grab these cases. And for instance, I'm going to go ahead and grab my laminate. So I'll grab, like in this case, I'll say von me stress, apply 1, add similar layers right here in the apply results. That way it goes ahead and it checks apply 4, apply 3, all the applies. So I don't have to go through it. Imagine you have a ton of applies, you don't have to do it. So it's going to go ahead and envelope that. So with that, I get my output for all output vectors. And I will post-process that information for all output vectors. And then each individual output, case 1, has now an envelope for those stress output that I requested. So if you are doing composite output, that's a good way to go ahead and look at those outputs. And you see I can go through the stress for each individual case as I go. They're pretty similar in this instance. That's all that I wanted to show you. I hope that was pretty informative. I'm going to go back into my PowerPoint for my conclusion. So I went through and showed you some tips and tricks using the output manipulation data surface data tables, along with what's new in Femap 2020.1. I didn't have a chance to show you everything in Femap 2020.1. There is a handout, as Andrea mentioned, on what's new in 2020.1. Please feel free to download it. If you have any other further questions, please feel free to reach us at Saratech. Thank you for your time.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.